Okay, so we're going to pretend we don't know anything about circles, and we're going to see if we can define a new way to measure an angle. So let's call this distance here a half, from the center of the circle to the outside edge. And let's say that if I'm measuring how much of the outside of the circle I'm traveling, that we'll call this distance the curve distance. So what I'm going to do is I'm going to say when I have a distance equal to a half, if I bend this around so that it curves around the curve, see if I can get it nice here. Close enough. Okay, now when I've gone 1/2 distance around the curve, I'm going to call that angle something new. So when the curve distance equals the half, I'm going to say the angle is 1/2ian. I'm just totally making up this new angle here, halfians. So 1/2ian would be that. So if I walk around the curve another half distance, then that would be 2/2ians. And if I walk 2.5, then that angle would be 2.5 halfians. So I'm always measuring the angles, but I'm using the ratio of the curve around the outside compared to the half distance. So that is 2/2, so this one is, or halfians, 3/2ians, right? This would be 4. This one would be 5, and this one would be 6/2ians. So we're a little bit over 6. If you look at this, it's going to be somewhere in the neighborhood of maybe 1/3 or so. Somewhere around 1/3. So once around the circle is going to be, in my new unit, 6 and maybe 1/3 halfians. Let's just call that HF for that. Or if I wanted to measure it really super exactly, I would get 6.28 halfians, or 3 times 3.14 halfians, or 2 pi halfians. Well, maybe you recognize this if you've learned it before as a unit that we actually have, which is 2 pi, instead of halfians, radians, which is just simply a ratio. It's a way to measure angles by using ratios. And we usually use L here to represent the curve, which is called the arc length, and we usually use R to represent the radius. So the ratio of the arc length to the radius is the definition of radians. And if you think about a circle, once around the circle, the distance for circumference is 2 pi r. And then when you divide by r, you end up with 2 pi radians. So that is how we get the idea of radians. It's a handy unit because it's just a ratio. So let me give you a couple of examples here. If I have 135 degrees, then how many radians is that? Well, I take 135 degrees and I say to myself, once around the circle is 2 pi radians, or 6 1/3 halfians or so, and that is also equal to 360 degrees. So when you multiply those together, you end up with something that is 0.75 pi radians, And that's probably how you leave your answer in math class, but in physics we tend to do more decimals, 2.36 radians for that. So 135 degrees is equal to 2.36 radians. Or a little bit more of a physics-y example, if you had something that was going 4.5 rotations in 20 seconds, then our definition of angular speed, rotational speed, is the angle it travels divided by the time. So that's 4.5 rotations divided by 20 seconds, or 0.225 rotations per second. But maybe I want to do it in radians, because radians isn't really a unit, it's really just a ratio. So that makes it easier to convert between one unit and another. And usually you're converting from linear to rotational or angular things. So take my angular speed, 2.225 rotations per second, multiply it by 2 pi radians for one rotation. Rotations cancel, and I end up with 1.41 radians per second. That's the same angular speed as about 1/4 of a rotation per second. Which makes it, excuse me, it makes sense because 6.28 radians would be once around the circle completely, and I'm about 1/4 away to 6.28, so that kind of makes sense with that.